single-minute exchange of dies. We've already done this. This is the intro. Okay, here's what we expect. First of all, we expect you to understand what setup reduction is when you get out of this class. Why it's important to lean processes and in achieving a world-class manufacturing organization. Factors that influence lead times, setup, basic concepts and steps required to implement a setup reduction program, how to properly analyze and set up operation through a proven step-by-step process using low-cost solutions and techniques. I'll repeat that. Low cost. This really doesn't cost that much money to set up and implement, okay? Most of it is common sense. A lot of it, you know, you're probably already doing some of it to start with, you just don't know it, and it may not be standardized through the whole set of operators. Like, old Bill does it, and he didn't even think about it, and he's really fast, but nobody else can do it as fast as old Bill. Okay, well, Bill's got it down, he's got it in his head, and this is how he does it, he's efficient. But old Bill don't share his information or teach anybody. Okay. How to develop effective performance measures to ensure you are obtaining the results necessary from the program. Okay, so what is setup time? Very important, first definition. Setup time is the amount of time that you make during a changeover from when you make the last good part until you make the next good part. Make sense? The elapsed time from the last part of the current run until the work center starts running the first good part of the next run. This part right here, good part, that's key because we don't count the 20 or so widgets you made during changeover trying to tweak it and adjust it and make sure it's within spec. That doesn't get counted as production, okay? Setup time is from the time you stop making part A until you're making a good part of part B. Right? Any questions so far? That's what we're going to define setup time as. Step 1, preparation step. How many of you change your own oil? How many of you have crawled under your truck or your car to change your oil and didn't get the oil filter wrench before you crawled all the way under there? At least once, come on. Alright? Well, if you're going to crawl up under your vehicle to work on it, it's kind of saves a lot of time and energy to get you a little box or bucket or something and drag all the stuff you think you need with you under the car. Or if you have children, you don't have to. You can skip that step. Okay.
Or your wife.
Your wife. Yeah. There we go. Wife or children, you can skip that step because that's their job to handle stuff. So work that is done to prepare for setup or changeover, finding materials, jigs, gauges, etc. And there's an approximate 30% of the setup process. So just getting ready to is just about 30% of the time. All right? Prep time. Mounting and dismounting step. This involves work for taking dies, cutter heads, blades, and other similar tooling off the equipment and putting on the new required tooling. Makes approximately 5% of the setup time. All right? Now, you know, SMED is single-minute exchange of dies is what SMED stands for, okay? And this was kind of developed for Toyota years ago when they were stamping out cars. You know, a unistamp, like a Volkswagen Bug, is a big stamp that stamps out one vehicle every time it crushes down on a piece of metal, uniframe body. So, when we talk about through this class about dies and cutter heads, that's not necessarily mean that it can't be applied to all different kinds of things. So keep that in mind and think, Well, what's he talking about? I'm talking about changeover, okay? I don't care if you're putting a dye in there or you're changing a brush or you're changing the paint, it doesn't matter. So, as we go through this class, don't worry about you see dyes inserted in here, that's technically on the book, but it can be applied to any changeover. Centering, dimensioning, and setting steps. Step number 3 involves fine-tuning the tooling and equipment to run the next part. Takes approximately 15% of the time. Okay? Here we go. So back here, alright, 30% of the changeover just getting ready for it, getting all your stuff together, right? 5% taking stuff off, putting it on. 15% fine-tuning, making sure it's all the bolts are tight and getting them in the right place for the right product. It's rough setup, rough adjustment. Here we go. 50% of your time is trial runs and adjustments. That's once you've changed over, you're running part B, and you run one part of part B, and then you take it off the line, and either you do it or you take it to QC, and QC stands there, and they do all their checks and go, this is good except for that. You need to adjust that. So you go over there and you adjust that, and you run one more part, and you take it to QC. And this goes back and forth until you're running an acceptable product, at which time setup is over. Okay? With me so far? Alright.
Is this just in this one SMED deal, or, I mean, seal's different. 50% of our time's not set up that way.
Well, this is generalization, okay?
Okay.
Doesn't mean you can't apply these principles to anything, okay? Somewhere, I mean, this is pretty common sense, what we're going to talk about, but there's keywords and buzzwords associated with changeover time, internal and external time, stuff like that we're going to cover. But I'm not saying, this says right here, this is where I get out of all those questions.
Yeah, okay, I'm with you.
It says approximately. So right there, I get out of all that. So, but, you know, I've seen a lot of changeovers. In fact, I've had to, my deal was I was a programmer, so if they did changeover, I could make adjustments to whatever. And a lot of times I was waiting on changeover so I could do my thing because I didn't want to do it while they were running. And whenever they had this 50% of the time, I was like, yeah, just keep messing it up because I'll be done and won't have to come back at midnight for the next one. So I've seen them. All right. Now you're going to ask, what is SMED? Okay. Well, there was this doctor, trying to remember the exact date, 50s, right after World War II, Dr. Shingo, and Toyota brought him in. They brought him in to say, the Germans are beating us on the Volkswagen on the production. What can we do to ramp up? I mean, he went to a lot of different factories, but over the years he went to his big one where he wrote his book called SMED was with Toyota. And so basically he come up with a way that they could change dyes in a minute. So he took, basically, we're going to get into that some more, but what used to take 3 hours, he got down to under 5 minutes, which is a big deal. We're going to talk about why that is a big deal. So from going from 3 to 5 hour changeover down to 3 minutes. You're not all going to do single minute, which is the ultimate goal, right? 1 minute per die. That's never going to happen, okay? So don't think I'm in here to preach to you miracles, because that's not going to happen. Okay? You remember last time we went over the OEE? Every widget you lost per shift added to quite a bit of money over the course of the... Remember that every minute was that much more money compounded. So it's not just that day that you're making money the entire life of the process if you can change it. So anyway, he came in and a little book, and I'm not going to bore you with it. Specifically focuses on jigs, and we're not going to get into that too much. If, however, you are somebody that's involved in dies and setup, I suggest you get the book. We're going to cover the first half, which talks about the theory and philosophy behind it and how to apply it to everybody. Okay. So, what is setup reduction? It is a process where the total time required to change over or set up equipment or work center is reduced through a systematic, proven approach to problem solving, waste eliminating, to support the movement towards small lot size runs. This will reduce inventory and increase productive runtime to achieve increase in throughput, minimizing lot sizes and reducing total cost. A lot of you are looking at me with a blank on my, you're like, what are you talking about? Well, we're going to see this, but basically it means a lot of companies will run product A because it's such a pain to set up for it. They will overproduce. They don't have orders for product A, but they'll make extra product A because it's such a pain to change over that they know, well, we're probably going to get so-and-so order, so we'll run X number over. And then they'll change over to product B. And, change over, they could take a day. So the theory behind setup reduction is we run smaller lot sizes, which means we run just what we need to product A. We reduce the changeover time to a minimum amount of time. That way we flip. So there will be, if we implement setup reduction properly, there will be more changeovers. Okay? The total number of changeovers should increase. The amount of time for each changeover should decrease. Because what we're going to do is we're going to do small batch processing. Instead of making all this inventory for stuff that we don't need because we waste all our downtime on changeovers, we're going to get our changeovers fast so we can flip around. A little bit of this, a little bit of that. Oh, it looks like we need to pick up over here, so before the changeover is ready, we'll just run an extra hour over here, and then we can flip back over to here to fill our production next week on this part. You got where I'm going with that? Instead of being dedicated to one product and filling up your warehouse, we'll just try to keep on the move. Just-in-time manufacturing. And I have my own, so yeah, I heard my just-in-time manufacturing. This kind of touches on that, but just-in-time means you only make what you need when you need it, and then you only buy the raw materials as you need to use them. So you buy steel plating, and that day you run that steel plating, and by the end of the day you've turned what you brought in the morning into a usable product at night for the customer. Well, basically it means no inventory, just in time. And I've never seen that work. Okay? Now, you can reduce inventory, and where that number needs to be, that depends on the process. Okay? You have to play with that. But I've never seen anybody, what happens is this just-in-time is, well, every time I've seen it try to implement so close that you had no inventory, you either had people standing around getting paid for nothing and sent home early, or you had customers screaming for their order, one or the other. Because they come in there and, well, we can't fill that order because we don't have the stuff, we're just going to have to start overproducing here and making inventory. So I've never seen it work. So we'll get that.
Who came up with it?
Huh?
Who came up with it?
Toyota.
Toyota?
Yeah,
They can make it work, but I don't think
we get success at Purple. We went to 1x1, where we were making box lots of products, and went down to 1x1 by the time we left Fort Smith here, but we were pretty successful. We commonized a lot of parts.
I'm not saying you can't get better. I'm just saying that, let me tell you Baldor's philosophy. Okay. Now, Baldor makes large motors, and if you need a large motor, your plant's in, because nobody is going to stock a $20,000 motor, okay? So at Baldor's, it works for them. They try to make all their motors of a certain size interchangeable, so they just make pieces. And if something like that happens, then they can just go grab, even if they have to take one motor apart, they can take one motor apart, change the facing on it, and make a big giant motor to send out in a hurry, because their product model is they're not selling to the individual consumer. They're basically selling to manufacturing who, you know, when they usually don't get any lead time on a large motor like that. They have a large 200 horsepower motor. It's pretty much got to be there today. And a lot of places spend more in air shipping 2 tons of motor than they do what the motor costs, but they'll do it. Because for them to spend that money and let it sit on a shelf for 10 years doesn't make sense. So they want to be able to pick up the phone, call the Baldor rep, and say, I need this, and by the end of the day have a motor in. Now, more efficiently speaking, if they had it sitting on the shelf, they could be up sooner. But anyway, the big deal around here is, since Baldor is down the road, nobody wants to stock motors because they can pretty much pick up the phone and call Baldor and have one in a little bit, right? That make a lot of sense. Further out in the boons you go, the more stock of motors you need. But somebody asked, did I get off tangent here? Somebody asked me a question about, okay. Anyway, I thought I got off. I get to talk and sometimes I forget what I started about. So, setup reduction. More setup, faster setups, so we can make smaller lot sizes. That's the point. Now, traditionally, we leave the setup change. We just tell employees to, we got to change over. Y'all take care of that. And what that is they often lack the resources and authority to make significant improvements to the setup process. We tell them to change over, and they start digging through the old bucket of rusty tools. We don't, you know, they need tools, they have to beg for them or buy their own. Another thing is outdated accounting practices. This is pretty much gone, but there are still some holdouts. That large lot size runs in order they spread the cost of timely and costly setup operations over the whole life of the product. Basically, the old way of thinking was, we've got to make up this downtime, so we're going to run big batches. Okay, so we got a buffer for these changeovers that take 8 hours. You with me so far? Old way was thinking, it's basically the accountants were saying, we're losing money here if we're not running. Okay, that was the old way of thinking. Basically, if you're not making something, you're losing money. That's not necessarily always the case. Sometimes, when you're making something and you don't need it, you're losing more money than if you just stopped. Okay? So what they're saying here is the old model of thinking takes hours and days instead of minutes. Most setups can be reduced by at least half. This says 90% with a focused approach using low-cost, no-cost techniques. You with me so far? Now, let's see, I've got some videos over here before I lose you. Let's see what I have over here. Okay. Here we go. I'm going to find out who Mr. Shingo is.
Dr. Shigeo Shingo was perhaps the greatest contributor to modern manufacturing practices. Dr. Shigeo Shingo was one of the greatest influences on Japanese quality control. His contributions to quality improvement revolutionized the Japanese industrial sector and consequently influenced the industries in the West. The just-in-time manufacturing concept was founded in part due to the contribution of Dr. Shigeo Shingo and Mr. Teiichi Ono of Toyota Motor Company. Dr. Shingo pioneered the concept of the single-minute exchange of die system, in which setup times are reduced from hours to minutes. This concept is especially beneficial as it allows the manufacturing system to quickly adjust to the changing customer requirements and the production schedule. It is also associated with the concept of the focal yoke, or the mistake-proof system. In view of his contributions, Utah State University founded the Shingo Prize for Excellence in Manufacturing in 1988. This prize promotes world-class manufacturing and recognizes companies that achieve superior customer satisfaction and business results.
I don't like to leave that. You ever notice that YouTube window, you leave in front of the class, there's no telling what will show up in that window once the video ends. I don't even know, there's no telling. So I'll try to get that video off there as quick as I can. I don't know why it does that.
I'd like to know how you judge this is the right component you want to use or not. My brain is very simple. I just want to look at the area where mistakes are made.
And that's
Try not to make a mistake in the very beginning, right here. Then look at that human operation. If that's where you make mistakes, you don't mistake after you have made a mistake. Don't make a mistake in the very beginning. I would like to concentrate on producing 100% good product. Okay, reduce it to zero. I'm not interested in hearing you. What we can do in Japan, you can do in the United States. There's no question about it. Down to zero. That's possible. That's possible. Then look at that human operation. One problem at a time.
That was an advertisement, I know. But. So, let me tell you something about Toyota. They basically give this information away, okay? You're asking, why do they do that? Kindness of their hearts? Yeah, I guess kind of, but, you know, they give it away, very few people follow it, or can follow it. But they just say, here, this is what we did, you know, if you can do it, we can do it. And for years, all the fat cats around in America and man, they were like Ford, GM, they're like, we don't care. Well, guess what? When people started buying, here's the whole drive behind it, okay? When people begin to realize, back in the late 50s, early 60s, that they could go buy an American-made car, and they could get 30,000 miles out of it before everything started breaking on it, and it was time to trade it in. Or they could go buy a Toyota and have everybody make fun of them, and they kept laughing until they had 200,000 miles on it and were still driving it. Okay? This deal where we get 200,000 miles out of a truck or a vehicle anymore, that didn't used to happen. If we bought a car, we were lucky to get 50,000 miles out of it before it's time to trade it off and get a new one. And now we're getting 200,000 miles out of a vehicle. And so when that started happening, everybody started going, well, maybe we can do this, because Toyota started getting a market share for dependability, you know. Plus their price was cheaper. So you can spend less money, get a better quality than you can American. Why wouldn't? That's what happened. Consumers started going that way. So we looked at that, and they said, well, here, this is what we're doing. And they said, okay, we're going to try this. Some of them implemented it. Some of them failed at it. Most of them failed at it until they finally got it right. And now you buy a Toyota, and it's made, a lot of it made in Kansas. Now you can buy, so, you know, where does it stop, where does it end? I don't know. Buy a Japanese car made in America, put American workers, they work to make it, so. Now, the problem with changing a setup reduction program in a plan is, but this is the way I've always done it. Old Joe has always done it this way. Old Joe has worked here for 50 years, and he'll be, I don't care what you tell me, and Old Joe will do whatever you tell him until you turn your back and he'll go back the way he used to. So that's the problem with setup reduction as far as the human element is concerned. So it also has to kind of be a mindset, all right? Now that comes about by, you know, you got to look at the bottom line here. How does Old Joe do it? Old Joe's good at it, but he doesn't like to tell anybody how he does it. They send people to train with Old Joe, and they come back just as clueless as they went in. Okay? Well, you figure out what Old Joe is doing, and you write it down on paper, and you take pictures, and you say, this is the way we're going to do it. And that comes in the form of an SOP, or standard operating procedure. Okay? Now, when we set up this, and we do the SOPs, and everybody's on board, and 6 months later, we're back to where we started. That's the human nature, is to always fall back. I'm going to start my diet. Okay, and you go good for the first few months, and then you're back to eating ice cream, fried chicken, and everything else. The problem that we have in America is we don't stick with our plans, so there is a component that there must be accountability. So along with having a setup reduction process, somebody has to have it on their calendar every 6 months to go around and audit people. How many people have been through an audit? Oh.
Everybody.
Oh, everybody's been through an audit. But that's the reason we do them. Because if we don't audit people, we don't know if they're doing what they're supposed to. So, now, we talked about some people believe that all setups can be done in 9 minutes or less, which is a misnomer. I've seen it say 5 minutes or less. The whole thing about single-minute exchange of dies is I think there was a machine with 9 dies, and they got it down to 9 minutes in a Toyota factory. They did. That was the record. That didn't mean they always hit it. But basically, they had all the employees on board with it. It was kind of like a contest, and they would start a changeover, and they'd start the stopwatch. They'd see how fast they could do that. Okay? So, what setup reduction is not? It's not a way to get rid of people. All right? And I know some of you've been in this program, you've probably heard that about lean and stuff. The whole purpose of lean and OEE, which I put in those data collection system that, basically tell you who's operating the machine, how fast they're running it, when they went to break. It's not the point is to have Big Brother watching you. It's not to eliminate, though I have seen it used to do that, but that's not the point of it. It's a way for us to compete globally in a global market. All right? I think we had this discussion about America cannot compete with foreign manufacturing when it comes to wages. We just can't do it. So how do we compete? We compete with quality and reduced waste. That's all we can do. All right? Now, I'm not saying, places like China, they beat us all the time. Has anybody seen what the atmosphere is like in China lately? They are trading their manufacturing for their environment. They are basically selling off their country. That's my opinion. But the air quality in China is so bad right now, it's horrible. Now, they don't have the EPA regulations, they don't have anybody watching them, they can do whatever they want to, they can basically pour chemicals right down the river, and then the people down the river drink it and get sick. They don't care. They have at one point, I think it's changing, they had so many people, they had plenty of workers. Well, if they drink out of this river and get sick and die, we'll just go find some over here and ship them in. Right? That's how China did it in the past. And I think they're having to change because now it's getting to the point where everybody's getting sick. The pollution is up. I mean, it's horrible. There were saw some videos the other day where they had a weird inverted air mass over some of the big cities, one of the big cities in China, and basically all the smog that was supposed to blow off came up and laid down, and basically you couldn't see 5 foot in front of your face for days. Okay, and basically the traffic stopped. You couldn't see to drive. That's how bad it was. So, anyway, we can't compete with foreign. This is the only way we can compete is reduce waste, reduce cost. So, what setup reduction is? It is a cost reduction tool. It's a low-cost method to achieve increased capacity from existing equipment. Right here. Well, if the time you save on the old widget maker machine that's been in there 50 years, if you reduce the changeover time, it might not be as fast as the new machine that costs $200,000 or $500,000 or whatever. But if you can change it over faster, that's that much time you have to produce. So an old machine can keep up with a new machine in a setup reduction changeover when you reduce the setup time. Does that make sense? If you reduce your setup time, you increase your capacity to produce because you have more time. Okay? Now, I know a lot of you watched the goal last time, and you remember talking about bottlenecks, right? Well, changeover helps reduce bottlenecks, okay? Because you free up machine time, all right? And we went back to talking about how the old way of thinking was that everybody had to be working. They have to be doing something. They're either goofing off and we're losing money. Well, the whole point of all this world-class manufacturing is to have a smooth process, okay? Maybe they're not working over here, all right? Maybe they've made the parts that they need to make. If they made any more parts, they're going to flood the floor with inventory. Nobody's going to be able to walk, and it's going to hurt the production downstream. So they get through making their parts, and then maybe they clean up. Or maybe they go somewhere else and help somebody. I mean, at Whirlpool, I know some of you in here from Whirlpool, how many times people made their parts. I've been in there and I've seen them. They made their parts and they were done their shift and they sit there and start playing cards. Okay, that was their quota. Now, are they goofing off? Well, they think they're goofing off maybe when they play cards, and they think they had a union contract that says they have to make that much. Or it could be that the powers that be figured out, well, to run this much production, we need this much quota. And we don't care. And they go to the union and says, we don't care about the hours. What we need is the X amount from this group to feed the next group the next day. And we don't want too much. We don't want too little. So people get done early, and they sit there and get paid to play cards or spades for an hour and a half. But they're doing their job, okay? There's that buffer in there. What if the line broke down in that time? Well, they wouldn't be able to play cards for an hour and a half. They'd have to work their full time. But what they did is they made the right amount of parts for the next process. And we didn't end up with a bottleneck. We didn't try to cram a lot of stuff down something that couldn't take it. So the purpose of setup reduction is to get that capacity back that we lost on setups. It means to have people who perform the work take ownership for the process and be involved in implementing solutions in their work area. Basically, that means management can't tell you how to set up the machine. Now, you're all looking at me like, but they do tell me how to set up the machine. Okay? Well, maybe they tell you how to use an existing SOP to set up the machine. This is the way it is. But that doesn't mean there's not a better way. You know, we're all talking continuous improvement. What's the key buzzword in continuous? Never ending. All right? So just because this is the way we did it last year, doesn't mean this is the way we need to do it this year. Now, that doesn't mean that you do it on your own and make an executive decision to change it, but maybe you should, you know, document your case and bring it up to management and say, hey, why don't we do this? Much easier. And hopefully if you got good bosses and all that, they'll look at it and they'll go, hey, well, let's try it. Do some little time studies on it. You know, that's simply taking the video camera out and looking at the time display and filming it the old way, and then you film it the new way, and whichever one is less, well, that's the better way, right? Not real complicated here. Of course, you probably want to do it 3 times just to make sure it's not a fluke, you know. So, why is it important to reduce setup? There's some key points here. This is probably one of those pages here you want to kind of put a star by, because this PowerPoint drags on. I know some of it's redundant, but we're going to pick out the good stuff. Reduce total process time, reduce lot sizes to minimum levels to achieve a smooth flow or a flow, instead of run, stop. Run, stop. How about if everybody just works a nice pace and everything goes through there smoothly? Okay. Reduce queue time, inventory. We improve flexibility. That means if we get a rush order in, then it's no big deal for us to stop making product A and switch over. Cost, increase capacity, and improve quality. All right. Part of setup reduction is how many widgets are you wasting when you change over? You know, there's you change over and you run one, and we talked about that. We make one widget, we take it to QC, and they see if it's good. And if it's good, they tell us to go. If it's not, then we make another widget. Well, every time you make a widget that doesn't work, that's out of spec, that's scrap. Okay? So how do we make changeovers that when we set it up, it's exactly where we want it to be? Well, think about it this way. Let me give you an example. Common sense approach. Let's say you've got some tooling that's on a slide bar. Alright? And so it goes somewhere in here, and for product A, it sets over here, and it hangs down in the line. It does whatever, and that's product A. Maybe it's a guide. And over here, we've got one for product B. Alright? And these have to be precise. This is going into a cutter. If they don't cut right, they're not the right width, and they fail. So, this is full of magic markers, where everybody's wrote where product A and B need to be over the years, and you don't even know what it is. And it's covered in so much paint, it looks like it's dripping off. Okay? Alright? So instead of having a slot adjustment where it can get out of whack, now there probably needs to be a little slot adjustment, but maybe, just maybe, we want to put some notches in here, so, and label them in nice labels that everybody can understand that product A goes over here and it fits in that notch. Okay? Now, if this gets whacked and it's all out of whack, then we've got a problem, right? But if that's the case, we don't have it secured good enough. So we need to figure out a way to secure it where it will never move and put notches in there. And if they get out of tolerance, Well, hopefully we need to have this drawn out and we just make a new one. Have somebody make us a new adjustment bar. We put it in, everything's in the right place, okay? But that's a way to improve quality, because now, if we do this correctly, as soon as we start making the next product, it will be a good product. Instead of coming over here and tapping this way 1/8 of an inch, or tapping it back the other way 1/8 of an inch, all right? And maybe the tooling down here, this tooling, whatever, maybe there's some tooling on the end, you know? Maybe we know this tooling wears out every 6 weeks. So why do we want to wait till 6 weeks before we figure it out and change it? Because it's cheaper, depending on what your widgets cost, to, hey, have a little spreadsheet and calendar reminder for, supervisor, there'd be somebody in charge of it, and say, instead of waiting for 6 weeks for this tool to wear out and then make bad widgets for an hour that we throw away, why don't we change this out regularly at 4 weeks or 5 weeks or whatever it is, instead of waiting for the tool to wear out? That kind of deal. Because it's cheaper to spend the extra money on tooling than it is to make bad widgets. Common sense, right? Okay. All right, take a little break. Okay. History of SMED, and that's posted online. So, we're gonna fly through this. We're flying through this document, and we're gonna skip over some stuff because we do have a plant simulation in here, and the plant simulation with this many people only have 2 dies, so we'll have to make that work as best we can. I certainly don't think 2 groups is going to work, but so remember. We're going to have a brief overview, and you're going to implement a quick changeover, okay? Basically, we're going to do it the wrong way, and then you're going to fix it and do it the right way. It's pretty common sense stuff. But a lot of people, you just don't think about stuff until somebody sets you down and goes, why don't we do it this way, all right? Kind of walk through it yourself. I'll tell you what I've often wondered about technology is we have all this technology to save us all this time, right? Does it? Because it seems to me I spend an awful lot of time messing with stuff to make it work right. That's just a thought. So, goals of setup reduction. Let me see if I can give you an example. Okay. So, you have a paper mill, all right? You're making a big roll of paper. When I say a big roll of paper, I mean it's 20 foot long, okay? Now, this roll of paper is subdivided. So you have this large sheet of paper, but let's just say I need a 5 foot section and I need a 6 foot roll, and it all goes on this one roll that you've loaded all these different size cardboard tubes on. And so when you're still making a 20 foot sheet of paper, but right when it comes out of the dryer, it has a cutter. So you're cutting off a little 5 foot roll. It's all going on the same roll, but when the roll comes off and they pull the rod out, then you've got X number of rolls of varying length. Does that make sense? You with me? It might help if I draw that. So you have one long rod, and this is a good example. How many people think that when they make toilet paper, they actually cut each piece of toilet paper on the roll? No, they have a long tube, and they put maybe 200 or 300 toilet paper rolls on here, and then they take one long sheet of paper, and they start rolling it up on here. And before it goes here, they have cutters, just like another rod up here that basically cuts these little strips so they go in the right spot, the right width, okay? And maybe toilet paper is such a good example because that's pretty standard, so it fits on the same roll, but there are varying lengths of paper cut. And so, if you need to change over, and change the size of paper you're cutting. Well, I don't know if anybody's seen a paper mill, but it's really hard to stop a paper mill process. You don't want to stop it, do you? Once it's going, it doesn't stop. Because it's such a pain to get going, it stays going. That don't matter what kind of paper comes off. So, they have a rotating, like a Gatling gun here, so it'll flip over, and they have special machines, electronics, that'll actually catch that paper as it's flying up in the air and put it on the next roll. Well, they set these up, and if you have two of these, you have two sets of cutters, so you adjust one set of cutter to get it where you want it. And when that happens, this arm flies up and it starts cutting a different length. And it all happens really fast, and it's quite amazing how you can see this 10-foot sheet of paper magically make this big sound go boom, boom, and then be right back rolling on another roll. But that's what happens. If anybody's been to Georgia Pacific, I'm talking rolls like this that you take forklifts to pick up. And then they can flip those over and change size. So basically, their setup is all external, and their only changeover time is maybe 1 second. And it's all designed that way because if they did it the old way, which I'm sure when they first started, they did it the old way, they would have to get the paper started, roll it, and then stop the run and start it back up, which is a 4-hour ordeal. And so now they don't have any setup time. Just instantly change over. That makes sense? All right. So, reduce lot sizes, lead time, inventory cost, because we don't have to make excess inventory because we're changing over faster, and increase flexibility through simplicity. Improve tool and product design, improve idle asset usage. That basically says if, let me explain that. Basically, instead of, well, if you have a machine setting idle, okay, and you can be using it for something else, okay, then during setup time, you could, that's not a good way to explain it. I'll come back to that one when I think of a good way to explain it. Increase capacity, productivity, reduce scrap. There's the biggie. Reduce scrap. What's the going price of copper right now? You know, I saw where I forget where it was. Oh, it was, I used to work next door. Copper fab. Anybody heard of copper fab? Fabrication. Apparently, just a week ago, somebody stole $30,000 worth of copper bars from the place. So, you know, if you're making something to do with copper, what's the scrap cost you? Improved maintenance cost, happier customers, and improved material flow and usage. So, basically what this is, you know, this is kind of redundant, some of this, but basically this is the lean of changeover, the setup reduction. And when I say lean, I mean just do what you need to, when you need to, as you need to, without any waste. Basically, just what you got to do to get the job done correctly and efficiently and repeatably. All right. Like I said, our goal is to basically get rid of setup. That's probably not always going to happen. As a minimum, you should try to always strive. See, we always set a goal when we do one of these projects. And what it's saying here is your goal should at least be 50% reduction in time. Doesn't mean you'll always achieve it, but, you know, what's the point of setting a goal you know you can make, right? There's no point in setting a goal that you're pretty sure you can make. I mean, that's just a given. A goal is something you strive for. If you don't make it the first time, you're supposed to think it over and redesign and try to make it the second attempt. But if you set a goal, so let me give you an example. I'm going to reduce waste by 2%. Well, you know what? That's probably one you're going to make pretty quickly just by not getting in a big hurry. All right? There's no point setting a goal that you know you can make. Basically, that says when you get to your goal, you need to set another one and try for that. So basically, this is a continuous process. All right? And a lot of companies spend a lot of money on consultants. It never ends. All right? Sometimes I think the money they save, they might just throw it away on consultants. But that being said, think about the fact that when we come in here, I ask you, did you want a book? Because some of you said you didn't. Because I don't want to cut down a tree for a book. You're going to toss, or you're a digital person and you don't care about a book. You'd rather have it on your laptop. So ultimately, we are saving resources, even though it might not directly affect the company. Saving resources affects us all, right? All right. And we had a little discussion about China, who didn't care about the pollution that went in the air and all that. And maybe we think we carry things just a little bit too far. But if you saw some of the pictures I saw, then you might think, well, maybe we don't. You know. Now, reduce lot sizes. You should reduce lot sizes only after you have successfully reduced the setup time. So basically, get your setup down and then start changing over faster. Okay? You with me so far? First, we reduce the setup time, and then we start trying to change over. Basically, that says if you reduce lot sizes before reducing setup process, it's pretty much guaranteed you will see an increase in cost per unit and erode any credibility to your lot size reduction strategy. So that basically all that says is you need to walk before you run. That's all that says. Okay? Get your changeovers down pat, and then start trying to change over more often. I have a video. And this guy, well, he does this. Here we talked about overpriced consultants. Here's one. But he put his video on there for free. Trying to hook you. I'm going to crank this up so people in back.
Hi there, my name is Ron Pereira, and I'd like to welcome you to the Gemba Academy Quick Changeover course. Now, in this first module, we're going to introduce quick changeover, as well as a powerful lean concept known as SMED, or Single Minute Exchange of Dies. And specifically, by the end of this module, you'll know what both quick changeover and SMED are, as well as why quick changeover is so important. And we'll wrap this module up by introducing the 8 steps to quick changeover. And lastly, similar to our Dealing with the 7 Deadly Waste course, we'll be visiting with the lean thinkers of RAM Technologies throughout this course as we witness an actual quick changeover event take place. But first things first, let's start off by defining exactly what we mean when we refer to a changeover. Well, formally defined, in manufacturing terms, a changeover is simply the amount of time taken to change a piece of equipment from producing the last good piece of a production lot to the first good piece of the next production lot. And if you work in a hospital or office area or any other non-manufacturing environment, simply replace the words last good piece with last good unit of one type of work. Now, one of the best ways to learn about quick changeover is to watch a pit crew operate at a Formula One or NASCAR race. It goes without saying that the ability to get the car back onto the track as quickly as possible can mean the difference between winning and losing. And so it is with the producers of any product or service. We too need to be able to get our equipment or value-added processes up and running as quickly as possible. Now, to make sure we have a good grasp of this definition, let's look at a simple example. First, let's assume we're running product A. Let's also assume we come to the end and we've successfully produced the product A and the machine stops running. Well, since the operator knows they must now get prepared to run product B, they begin the changeover process, which might include gathering the needed parts, tools, drawings, paperwork, and work instructions. Well, all of this results in machine downtime, which is pure muda, or waste, since no value is being created for the end customer. Finally, after some time, the operator is able to get the machine ramped up and is busy fine-tuning and tweaking things as they produce the first good part, which we're calling product B here. Now, once the operator has successfully produced the product B, the changeover is complete. Okay, well, let's envision the worst-case scenario. Let's imagine the operator has made it all the way to the end and has produced the product B, only to learn it's defective in some way. Well, the question is the changeover complete or not? Well, the answer is no, it's not, since, again, the definition of a changeover is the amount of time taken to change a piece of equipment from producing the last good piece of a production lot to the first good piece of the next production lot. All right, so that's what changeover is. Now let's learn what this thing called SMED is all about. Well, SMED, which stands for Single Minute Exchange of Dies, is a system focused on dramatically reducing the time it takes to perform changeovers, or setups, as they're often called. SMED was actually developed 50 years ago by a man named Shigeo Shingo, who was working for the Toyota